It's crazy to think that people used AM radio to check whether a transducer is pinging. Now, step 1 is to look at the LED. This tells me it's receiving power and whether it's pinging or in command mode. Next, there's a built-in test which is implemented to give straightforward information regarding firmware, auxiliary sensors, and correlation and amplitude profiles. When available, dipping the system into water gives a tremendous amount of insight. While it's in the water, I typically look at the distance to bottom, the velocity matches my expectation, and if enabled, whether the amplitude profile is reasonable. However, with thrusters becoming smaller, the number of electronics on board increasing, and conflicting acoustic sensors, there are several noise sources being added to the DVL's environment. Noise may either be acoustic or electronic. The consequence of noise being picked up by the DVL may not be apparent at low altitudes, but as altitude increases, it may appear in the form of reduced bottom tracking range. In the case of color noise, it will bias the velocity estimates and degrade the quality of navigation. To combat noise, we've introduced a power filter and a larger and more effective grounding plate. If there's still uncertainty or need for quantitative testing, the spectrum analyzer allows me to truly see what the DVL sees. Plots showing frequency on the x-axis and amplitude on the y-axis will help point out any spikes or signs of interference in the DVL's operating band. Finally, when I'm still in doubt about my system's performance, I check our support pages online and FAQs. These guides are written together with our engineers and with system integrators in mind to help guide the user in a step-by-step manner to identifying noise issues.